Hello, my name is Dhruv Babu. I'm in honors math. I'm currently undeclared, and I will be asking Professor Sue-Ann Campbell a couple questions about mathematical physics. Professor, do you mind introducing yourself a bit?
Hi, I'm Sue-Ann Campbell. I'm a professor in the Department of Applied Mathematics. I'm also the Associate Chair for Undergraduate Studies and the Advisor for Mathematical Physics.
Thanks for the introduction, Professor. Could you please describe what mathematical physics is about?
Mathematical physics is about trying to understand the mathematical and theoretical underpinnings of the laws of nature. So this can be anything from the very small scales, quantum mechanics, nanotechnology, to the really large scale, like the origin of the universe and galaxies and things like that.
Very interesting. So what do you wish students knew before selecting this as their major?
Mathematical physics is a really tough major. It's like layering a physics, most of a physics major on top of your applied math major. So if you choose this major, every semester you'll be taking a lot of math and physics. Some semesters that's all you'll be taking. It's a really great, interesting major, and if you want a big challenge, it's the great major for you.
So, Professor, what do you enjoy about this field? What do you love about mathematical physics?
Well, I really like the fact that you're thinking about big questions, as I said, like the origin of the universe. Other types of questions that come up that use mathematical physics is things like climate modeling. And so you're looking at really fundamental, interesting questions, but you're using complicated math to help understand that.
What types of careers can you expect to pursue with this degree?
So a lot of our mathematical physics majors, these are really strong students. A lot of them go on into graduate school, of course, and do different things after that. But I would say the big fields are, some can go into aerospace industry, a little bit in environment. So the whole climate modeling thing can lead you into that side of things. An emerging field right now is quantum computing. We're hearing about that all the time, right? So that used to be more theoretical, but that's maybe now an actual job prospect for people who do mathematical physics. So.
All right, thanks. And how is mathematical physics different from, say, A math or mathematical physics from the science faculty?
Right. So as I mentioned, the mathematical physics, you take all these physics courses on top of the applied math degree. So it's really layering a whole bunch more on top of it. So that's kind of the big difference there. Your electives are very prescribed with the mathematical physics degree. In terms of the mathematical physics as offered by science versus the one offered by math, they're very similar. The big differences are in the first year. So if you're a math major, you're taking the math core courses, which includes computer science and algebra, and the communication skills. Whereas if you're in science in first year, you're taking science courses like chemistry or biology and some labs. So the big difference is in first year. When you get into the upper year, the requirements are very similar. And if you do follow a math physics degree, what you'll find is in your courses, it's full of science majors and math majors. So you're taking a lot of the same courses together.
Thanks for answering all my questions. I guess we'll see you on campus.
Yeah, thank you for having me today, and I hope that maybe you'll think about doing a mathematical physics major.
Sure will. Thanks.